Welcome to the deep dive. Today we're looking at governance, risk, and compliance, or GRC. And, well, traditional GRC seems a bit stuck in a time warp, doesn't it?
It really does. It's kind of having a major blockbuster moment, trying to operate in the age of Netflix.
Exactly. Trying to survive using these old methods designed for a world that, frankly, just doesn't exist anymore.
It's totally that. We're talking about this documentation-heavy, checklist-driven approach. It was fine for static on-premises environments, those predictable video store aisles, like you said.
Right.
But now it's desperately trying to keep pace in this super dynamic cloud-native world, where thousands of servers might spin up and down every single second.
Yeah, the scale is just different.
The old model simply cannot scale. It just breaks.
And you see this pattern with disruptors, right?
Mm-hmm.
The leaders who drive these revolutions, they understand you need a complete reset. It's like Reed Hastings at Netflix.
Mm-hmm.
He didn't ask, how do we implement a better DVD rental business? Did he?
No, absolutely not. He asked the fundamental question, how do people really want to consume entertainment? He went back to first principles.
Which led to streaming, obviously.
And it's the same pattern you see with Tesla or SpaceX. They weren't focused on just incremental improvements, making slightly better cars or rockets based on the old designs.
They asked fundamental questions about physics, about manufacturing, about software.
Exactly. So if you're currently focused on making your internal GRC documentation and checklist processes just a little bit more efficient, well, you're probably Blockbuster trying to hang on to those physical DVDs.
Ouch. True.
GRC engineering, this shift we're talking about, it's moving from managing paper trails, essentially, to managing code and data. It's a fundamental change in the medium.
So today our mission is to really deep dive into this first principles revolution in GRC. We want to explore how you can stop focusing so much on those compliance checklists.
Which are always out of date anyway.
Right. And start actually engineering security and governance directly into your AWS cloud infrastructure. And the goal here isn't just ticking boxes. It's about creating a massive competitive advantage.
Yeah, we've synthesized what you really need to know. We'll start with the philosophical grounding, that why. We'll cover the 4 transformative questions that can totally restructure your security strategy.
Yeah.
Then we'll get hands-on with the toolkit, the 5 essential AWS services that form your automated compliance backbone. These are the building blocks.
And then the payoff.
And then the payoff, yeah. A deep dive into the FAFO case study. It shows exactly how one company applied these principles in the real world and cut their audit preparation time by a, frankly, stunning 87%.
87%. That's huge. Okay, let's get into it.
Good.
Section 1, the first principles revolution, really digging into that core philosophical shift. The why. We need to stop thinking like traditional auditors and start thinking like engineers.
So the absolute foundational difference between traditional GRC and this new engineering approach, it really boils down to changing one fundamental question you ask yourself.
Okay, what's the question?
Traditional GRC basically asks, how do we implement this compliance framework, SOC2, NIST, whatever better? How do we make sure we get a cleaner audit report this time?
Right, it's framework-centric. How do we satisfy the auditor?
Exactly. But the first principles GRC model, it just changes the subject completely. It asks, what are we actually trying to protect here? And what's the most effective, most efficient way to protect that specific thing, regardless of what the old standard document might say?
That feels like a much more powerful question.
Oh, the transformation is immediate. It's dramatic. The sources we looked at really emphasize that the answer to that question instantly turns security from being seen as this overhead cost center.
You know, the necessary evil.
Right, into a genuine business-enabling competitive advantage. Because when compliance is engineered properly, it actually increases customer trust, it lowers operational costs, and crucially, it speeds up deployment cycles.
Okay, I can see that. It reminds me so clearly of the Tesla analogy you mentioned earlier, but applied specifically to regulatory compliance.
How so?
Well, traditional automakers, they focus on iterating existing processes, right? Slightly better safety features based on the old crash test paradigms, maybe better documentation around those tests. It's all incremental.
Yeah, tweaking the existing model.
While Tesla focused on that first principle of transportation safety, how do we make this thing continuously safer in real time, driven by software?
Right. Their cars actively detect threats, they adapt to new traffic patterns, they improve their own defenses through over-the-air updates. It's dynamic. Traditional compliance, on the other hand, it only captures these static, point-in-time snapshots, like a quarterly review or an annual audit.
Which is already out of date the moment it's printed.
Pretty much.
So the analogy for GRC engineering is, instead of just checking static configurations once a year.
Which might have drifted the day after the check.
Exactly. GRC engineering builds systems that automatically detect non-compliance, they automatically remediate security drift, and they continuously improve the control effectiveness in real time. It's like the system is learning.
Instead of just testing against known historical scenarios, your controls actually get smarter because they're instrumented with live data. They react to the present.
And this strategic shift, you mentioned it's deeply influenced by Amazon's own internal philosophy.
Yeah, their working backwards philosophy. It's key here. Traditional GRC tends to work forwards. You start with regulations written years, maybe decades ago, SOC 2, NIST, PCI DSS.
Things designed before the cloud even existed, often.
Often, yeah. And then you try to retroactively force your modern, highly dynamic cloud environment to fit into those rigid legacy requirements. It's awkward.
Working backwards flips that whole hierarchy of priorities, doesn't it?
Completely. It starts with the desired business outcome. It's almost like writing the successful press release for the secure, compliant product before you even start building it.
Okay, so what are those core outcomes you start with?
The source material really drills down on 4. First, customer trust. That means ensuring data is genuinely protected and always available when needed.
Foundational.
Second, operational resilience, ensuring the business can actually continue operating during failures or attacks. Third, regulatory compliance, but seen as an efficient byproduct of good engineering, not the primary goal itself.
Ah, that's a key distinction.
And fourth, risk management, giving leadership quantifiable confidence that risks are understood and managed, not just guessed at.
So when you start by asking, what does the press release need to say about our security posture, you stop asking, what specific clause does SOC 2 require here?
Right. You start asking, what would our customers actually need to see? What proof do they need to truly trust our security? And that immediately reshapes the entire engineering effort from just satisfying an auditor to genuinely delighting, or at least reassuring, a customer.
Okay, that reframing makes sense. And you also mentioned influences from Google's SRE discipline, site reliability engineering.
Yes, absolutely. SRE basically transformed IT operations by asking, what if we approach operations and infrastructure just like software development?
Treating infrastructure as code, basically.
And treating controls as code, too. GRC engineering translates those SRE principles directly. A big one is the concept of error budgets.
Okay, error budgets. Traditional compliance seems to push for perfect compliance, 0 defects, right?
It does, which is often unrealistic and incredibly expensive. GRC engineering, borrowing from SRE, accepts that some degree of risk or failure is inevitable, especially at scale. Error budgets define acceptable levels of risk for specific systems or processes.
So you're not aiming for 0 failures, but staying within a calculated tolerance.
Exactly. You engineer systems to operate reliably within those defined boundaries. This maximizes business value. You're not overspending on perfection, but it also gives you critical data-driven insight into exactly when your risk tolerance is breached. You know when to react.
But hang on, doesn't that inherently contradict what an auditor typically wants? That 0 exception report. If you go to an auditor and say, well, we have an acceptable error budget for, say, failed patches on our non-critical dev servers, wouldn't they immediately flag that as a finding?
That's where the engineering mindset and the data become absolutely vital. You have to shift the conversation. You don't just say, oh, we have a few manual exceptions here and there.
Right.
You say, we have instrumented our patching system end to end. We can demonstrate that the failure rate for patching these specific non-critical assets has never exceeded 1% over any 30-day rolling period, and we have automated alerts that fire if that threshold is approached. Here's the dashboard showing the continuous monitoring data.
Oh, so the measurement and the automated response become the proof of control, even with minor failures inside the budget.
Precisely. The data proves you are managing the risk proactively and consistently, even if it's not 0 risk.
Okay, that makes sense. And that leads directly to the next SRE principle you mentioned, automation.
It does. SRE mandates eliminating manual processes that just don't scale. For GRC engineering, the challenge is simple but really powerful. If a control relies on someone manually reviewing something, manually documenting it, or manually fixing it,
It's probably not going to keep up as your cloud environment scales and changes, right?
exactly, it becomes a bottleneck and a source of inconsistency and error. That's why GRC engineers prioritize controls they can actually turn into reliable, automated code.
Which naturally leads to measurement.
You got it. You can't improve what you can't measure. And you absolutely cannot prove security or compliance without data. GRC engineering insists on instrumenting everything, configurations, access patterns, control effectiveness, so that compliance evidence becomes this continuous real-time stream, not a frantic scramble every quarter or year to gather screenshots.
And the last one.
Learning from failure. This is crucial. When controls fail, maybe an automated patch deployment misses a specific server or a configuration drifts. It's not treated primarily as a policy deficiency that requires updating some Word document.
You don't just update the procedure manual.
No. You treat it as an engineering problem. You ask, why did the automation fail? Was the inventory incomplete? Was there a race condition? You improve the underlying deployment system, the code, the monitoring. You fix the system, not just the symptom or the paperwork.
Okay, so this whole philosophy, these principles, they seem to culminate in the 4 key questions you mentioned earlier, the ones that fundamentally change how you approach every security and compliance decision.
That's right. This is the strategic framework that moves from the conceptual, the why, to the actionable how.
Let's hear them.
Question 1. What are we actually trying to protect? This forces you to get really specific. Move beyond generic terms like customer data.
Be more precise.
Exactly. Are you protecting your proprietary recommendation algorithm? Is it the customer's guaranteed service level agreement, SLA, on data availability that's critical? What specific assets, data flows, or competitive advantages are absolutely non-negotiable for your business?
And that specificity drives better engineering decisions, presumably?
Totally. If I know I'm primarily protecting the availability SLA, say maintaining 4 nines of uptime is paramount, then I'm going to invest heavily in things like multi-region redundancy, robust failover testing, chaos engineering, perhaps.
Okay.
But if I'm protecting a specific, highly sensitive competitive algorithm, maybe my biggest investments go into extremely tight encryption, sophisticated key management, and granular IAM controls around the code repository where that algorithm lives. The what dictates the how.
Makes sense. What's question 2?
Question 2. What would failure really cost us? This is about getting real with impact. You absolutely must stop relying on those abstract qualitative scales like high, medium, or low risk. They're too subjective.
So quantify it.
You have to quantify the impact in concrete business terms. What's the average customer churn rate we'd expect following a significant data breach? What are the potential regulatory fines in our specific jurisdictions? What's the estimated lost revenue per hour during a critical system outage?
But quantifying risk like that is notoriously difficult, isn't it? It feels very subjective sometimes. How does that calculation actually look in practice, and how does it realistically change an engineering decision on the ground?
It is hard, but even approximate quantification is better than pure guesswork. So a traditional risk assessment might rate, say, a missing patch on a non-critical internal server as medium technical risk. Standard procedure might put it in the 30-day patching window. But a GRC engineer, applying this business cost principle, digs deeper. They discover, maybe through system mapping or talking to finance, hold on, this non-critical server actually hosts our internal billing system. If it fails, we literally cannot invoice customers for potentially 48 hours. Based on our average daily invoicing, that translates directly to maybe $500,000 in immediate cash flow risk, plus potential contractual penalties. Now suddenly, the priority of that patch deployment is dramatically elevated.
Because it's tied to cash flow, not just some abstract CVE score.
Exactly. You're allocating your limited security budget and engineering time based on tangible business impact, not just technical severity checklists.
Got it. Very powerful. Question 3.
Question 3. How do we know our protections are actually working? This is critical. Implementing a control isn't enough. Shipping the feature isn't enough. You need continuous validation that the control is effective under real-world conditions right now.
So not just checking the box that says encryption implemented.
No. You need proof the encryption is functioning securely today. Are the keys being rotated correctly according to policy? Are the access policies on the key management service, KMS, actually enforcing least privilege effectively? Can you demonstrate that?
It's the difference between proving intent like, our policy document says we use encryption.
And proving fact like, here's a real-time dashboard fed by AWS Config and Security Hub showing that 100% of our production data stores are currently encrypted using the approved KMS key, and here's the log of the last successful key rotation. One is aspirational, the other is evidence.
Okay. And the final question.
Question 4. How do we improve faster than the threats evolve? GRC engineering treats compliance and security not as a static state you achieve once and then just maintain.
Like getting the certificate on the wall.
Right. It treats it as a continuous capability that you have to actively develop and improve over time. The fundamental question is, are we getting better at managing our specific risks faster than our risk environment? New vulnerabilities, new adversary tactics, new regulations is getting worse.
And if the answer is no,
If the answer is no, then your engineering approach, your improvement velocity is fundamentally failing, regardless of how clean your last audit report was. You're falling behind.
wow. Okay, asking those 4 questions consistently, I can see how that forces you out of that static, checklist-driven blockbuster mindset.
It pushes you directly into the GRC engineering discipline. It changes the entire conversation.
Okay, that provides a really solid philosophical why. Now let's tackle the more technical what and how. What is GRC engineering, really, in practice? You said it solves the problem that manual GRC just can't keep pace with the cloud's velocity.
That's the core problem, yeah. It's drift. In the cloud, servers spin up and down automatically based on load. Configurations change constantly through code deployments or auto-scaling actions. The traditional approach, manual evidence gathering, maybe quarterly reviews, it's obsolete almost instantly. The report is a historical document the moment it's finished.
So what's the GRC engineering solution?
The core solution is pretty radical compared to the old way. You build the compliance and security rules directly into the infrastructure lifecycle itself. You engineer the system to make it functionally impossible, or at least extremely difficult and automatically corrected, to deploy non-compliant resources in the first place.
Okay, so this is that shift from finding problems after the fact.
To actively preventing them from ever happening.
Like instead of a human manually checking S3 bucket encryption settings during an annual audit.
You write code, maybe a service control policy or a config rule with auto-remediation that actively prevents an unencrypted bucket from being created, period. Or if one somehow slips through a gap, it automatically encrypts it within seconds. The window of non-compliance shrinks dramatically.
And this preventative approach, you mentioned, it rests on 4 essential pillars for implementation.
That's right. 4 key pillars. Pillar 1 is just relentless automation. This is all about eliminating manual, repeatable work wherever possible, not just for efficiency, but crucially for consistency and reducing human error across a large, complex environment.
So what kind of things fall under automation here?
Oh, tons. Automated vulnerability scanning integrated into the CI/CD pipeline, scheduled rotation of access keys and secrets, automated OS patching, using services like AWS Systems Manager, real-time generation of compliance reports directly from live data.
Yeah.
Anything repetitive that a script can do reliably.
Okay, pillar 1, automation. What's pillar 2?
Pillar 2 is infrastructure as code, or IAC. This is fundamental. It means treating your entire cloud infrastructure, the networks, the virtual machines, the databases, the storage buckets, everything like software. You define it declaratively in code files.
Using tools like AWS CloudFormation or maybe Terraform.
Exactly. The benefits for GRC are massive. First, repeatability. You can stamp out identical compliant environments easily. Second, version control. You have a perfect Git history of every single configuration change ever made to your infrastructure.
That's huge for audits?
It's gold for audits. And third, the IAC code itself becomes your most accurate, up-to-date, living documentation of how your environment is actually configured. Forget dusty Visio diagrams.
The code is the proof of the controls design.
Precisely. Auditors can literally review your CloudFormation templates to confirm that, say, all production S3 buckets are defined with mandatory server-side encryption flags turned on. The intent is codified.
Okay. Automation and IAC.
Pillar 3. Pillar 3 is CI/CD integration. Continuous integration and continuous delivery. This means you embed automated compliance and security checks directly into your software deployment pipelines.
So before code even gets close to production.
Way before. As developers commit code, the pipeline automatically runs checks like static code analysis for security flaws, SAT, checks for hard-coded secrets, dependency vulnerability scans, and security configuration tests against your IAC templates.
And if something fails?
If a check fails, the pipeline stops. The deployment is blocked early in the development lifecycle. This is often called shifting left on security catching issues much earlier when they're far cheaper and faster to fix.
Yeah, shifting left is crucial. Fixing a security vulnerability discovered in production is exponentially more expensive and stressful than catching it automatically in the pipeline before it ever deploys.
Absolutely. CI/CD integration ensures that these security gates are mandatory and unavoidable. If your code or infrastructure definition fails the security test defined by GRC engineering, it simply doesn't get deployed. End of story.
But doesn't that risk creating friction? Blocking deployments could lead to development teams getting frustrated and maybe trying to find ways around the process. Doesn't the GRC engineer risk becoming the dreaded Department of No?
That is a key challenge, and honestly, it's where the engineering part of GRC engineer is critical. They
Hmm.
can't just be rule enforcers, they have to be enablers. The goal isn't just to block a bad deployment, it's to provide instant, actionable, contextual feedback within the pipeline.
So not just build failed.
Exactly. The pipeline shouldn't just fail silently. It should tell the developer why it failed in clear terms. Deployment failed because the S3 bucket definition user data bucket in your template is missing the required server-side encryption configuration attribute. Please refer to our internal standard template X or add lines 4750 from this example to fix it.
So it moves from just saying you failed to here's the specific problem and here's the pre-approved secure template or code snippet that will pass the check.
Exactly. It guides them towards the secure path of least resistance. That's how you move from being perceived as a blocker to being an enabler of secure speed.
Okay, that makes a lot of sense. Automation, ISC, CI/CD integration. What's the fourth pillar?
Pillar 4 is policy as code. This is kind of the ultimate enforcement layer, building on the others. Instead of writing your security and compliance rules down in some static PDF document that lives on a SharePoint site somewhere, gathering dust.
Which nobody reads after the audit.
Pretty much. You turn those critical compliance rules into executable code that actively enforces the rules automatically, often using cloud-native tools or frameworks like Open Policy Agent, OPA.
So give me an example. How does no public S3 buckets become code?
Okay, there are a few ways. You could use an AWS Service Control Policy, SCP, which we'll discuss more, to literally block the S3.putBucket public access block API call if it's trying to allow public access. That's
Okay.
preventative.
Okay.
Or, perhaps more elegantly for some scenarios, you could use an AWS config rule coupled with a Lambda function. The config rule detects a bucket becoming public, which triggers the Lambda function, which automatically runs code to instantly revert the setting back to private.
So it auto-remediates the violation within seconds or minutes.
Yeah, making the window of actual exposure negligible. The policy isn't just a statement, it's an active, self-enforcing piece of software.
Wow. Okay, these four pillars. Automation, IAC, CI/CD, policy as code. They really paint a picture of a fundamentally different way to manage GRC. And this system, it clearly redefines the role of the GRC professional into this GRC engineer.
Absolutely. They sit right at that crucial intersection of compliance knowledge and deep technology skills.
So what are the specific skills needed? It sounds like a demanding mix.
Yes, they need to be polyglots, really. On the technical side, deep mastery of cloud platforms like AWS is table stakes, proficiency with IAC tools, CloudFormation, Terraform, strong coding ability, particularly in Python, for automation and data analysis using libraries like Boto3 and Pandas, and definitely experience with CI/CD systems, Jenkins, GitLab CI, GitHub Actions, whatever the org uses.
That's a serious tech stack, but then they need the other side too.
Absolutely. They must pair that deep technical knowledge with solid compliance understanding. They need to understand the intent behind frameworks like SOC2, PCI DSS, GDPR, GPA. They need strong skills in risk assessment methodologies, control mapping, and understanding the audit process from the inside.
So they can speak both languages, tech and compliance.
Fluently. And the ultimate outcome of having people with this blended skill set is transformative for the organization. GRC engineers move from being reactive, finding problems during those stressful annual audits, to being proactive, preventing those problems from ever reaching production.
And maybe most importantly,
And perhaps most importantly, they shift from being perceived as purely enforcement, telling teams what they did wrong after the fact, to becoming genuine enablement partners. They provide the pre-approved, secure by default templates, the automated pipelines, the clear feedback loops that help development teams build innovative products fast and securely right from the start. It aligns security with business philosophy.
okay, so to actually build this kind of automated, self-enforcing GRC system on AWS, you obviously need to use the right tools, integrated in the right way. We should probably start with the foundation, the shared responsibility model.
All right, definitely worth a quick refresher. It's fundamental to cloud security. AWS secures the cloud itself, the physical data centers, the underlying network, the hardware, the virtualization layer. That's their part.
And the customer?
You, the customer, are responsible for securing what you put in the cloud. That means your data, your applications, your operating systems, your network configurations, and critically, your identity and access management, IAM, settings.
So our focus here is squarely on providing you, the listener, with the AWS toolkit and the strategies to secure your side of that model effectively and in a way that makes your controls continuously provable.
Exactly. It's about leveraging AWS services to meet your compliance obligations within that model.
Okay, let's break down what you called the 5 essential services, the ones that really form the backbone of GRC engineering in AWS, and crucially, how they work together because the integration seems key.
Totally. First up, you have AWS Config. Think of Config as the configuration detective.
Okay, a detective. Why?
Because it meticulously tracks nearly every single configuration change made to your supported AWS resources over time. If an encryption setting gets disabled on an RDS database, Config records it. If a security group rule is opened up, Config records it. It builds a detailed history.
And auditors love this, you said.
Auditors adore AWS Config. It answers 2 critical questions with immutable, time-stamped evidence. First, what exactly did our AWS environment configuration look like on any specific day in the past? Maybe the first day of the audit period. Second, when exactly did this critical security setting change, and who or what changed it? It provides that foundational historical ledger.
Okay, config is the historian. What's next?
Next, we have Security Hub. This is your compliance command center.
Command center, centralization.
Exactly. Security Hub acts as the central aggregation point for security findings from multiple AWS services and even third-party tools. Findings from AWS GuardDuty, which detects threats, from Config itself, detecting misconfigurations against rules, from AWS Inspector, vulnerability scans, potentially from partner tools. They all get normalized into a standard format.
We'll talk about that format later, ASFF.
Yep, the Amazon Security Finding Format, ASFF. Security Hub ingests these ASFF findings and centralizes them into one dashboard. Crucially, it maps these findings against compliance standards like the AWS Foundational Security Best Practices, FSBP, or the CIS benchmarks, giving you a unified compliance score and status view.
So it brings disparate alerts together into a single pane of glass focused on compliance status.
Precisely. It reduces the noise and gives you a prioritized view.
Okay. Config, Security Hub.
Then there's CloudTrail. Think of CloudTrail as the activity auditor.
Activity auditor logging actions.
Every single API call made in your AWS account. Doesn't matter if it's a human clicking a button in the management console, an SDK call from a script, or an automated service action. CloudTrail records who or what made the call, when they made it, from what IP address, and what the action was.
It's the ultimate audit trail.
It is the undeniable receipts for everything that happens in your account. It's essential for proving your controls are operating as intended, for forensic investigations during an incident, and for demonstrating compliance around change control and access logging. It proves both intent, who tried to do something, and action, what actually happened.
Critical. Okay, 4th essential service.
IAM, Identity and Access Management. This is the access controller.
The gatekeeper.
Absolute gatekeeper. IAM manages all permissions. Who can access what resources, and what actions can they perform? It's where you enforce the principle of least privilege, getting your IAM policies, user roles, and permission boundaries wrong. Well, pretty much everything else security-wise falls apart.
Because if someone unauthorized can change the config or disable the logging,
then all your other controls are potentially bypassed. Strong IAM is the bedrock upon which all other AWS security rests. The secure configuration of every single resource ultimately relies on IAM correctly restricting access to change it.
Okay, super important. And the 5th service that ties it together for audits.
And finally, the service that really streamlines the audit process itself, AWS Audit Manager. This is the evidence collector.
Evidence collector. How does it do that?
Audit Manager automates the collection, organization, and management of evidence required for specific compliance frameworks like SOC 2, APS, PCI DSS, GDPR, and many others. Instead of your team manually downloading logs, taking screenshots of configurations, and pasting them into spreadsheets.
The typical audit scramble.
Exactly. Audit Manager automatically pulls relevant evidence directly from sources like CloudTrail logs, config conformance pack results, and Security Hub findings, mapping it directly to the specific requirements of the chosen framework.
So it transforms audit preparation from that panicked, weeks-long scramble into a much more routine, almost continuous report generation task.
That's the goal. Ideally, it becomes push-button reporting for large parts of the audit.
Okay, config, Security Hub, CloudTrail, IAM, Audit Manager. The power clearly isn't just in the individual tools, but how they integrate, right?
Absolutely. You can build really powerful automated workflows. For example, AWS Config detects a misconfiguration, like a publicly accessible S3 bucket.
Okay.
That config finding can automatically trigger an event in Amazon EventBridge. EventBridge, in turn, can trigger a specific remediation Lambda function you've written.
The auto remediation we talked about.
Yeah, the Lambda function uses the AWS API to fix the S3 bucket setting. CloudTrail logs the API call made by config to detect the issue, the EventBridge trigger, and the Lambda function's successful remediation action.
In Audit Manager.
And then Audit Manager, configured for your SOC2 assessment, automatically collects the relevant config rule result and the CloudTrail logs showing the detection and remediation, filing it as evidence for the relevant control, like configuration management or incident response.
Wow. So it becomes this seamless, self-documenting, self-healing compliance system that's working 24/7.
That's the ideal state GRC engineering aims for, minimizing manual intervention and maximizing provable automation.
This brings us back to proactive enforcement. You mentioned infrastructure as code ensures secure deployment initially, but what prevents things from drifting later or someone manually making a non-compliant change? You mentioned service control policies, SCPs.
Right. SCPs are a crucial layer building on IAC. IAC handles the desired state deployment, but STPs act as organizational-level guardrails. They set hard, non-negotiable boundaries on what actions are even possible within an AWS account or organizational unit, OU.
Let's revisit that analogy. IAM is like your personal office access badge, letting you into specific rooms.
While SCPs are like the building-wide fire code enforced by the landlord, that fire code might say no blocking fire exits, and that rule overrides your personal access badge, even if you're the CEO. You still can't block the fire exit.
Okay, so technically, how do SCPs actually override even powerful IAM privileges, like an administrator?
It comes down to the policy evaluation logic hierarchy in AWS organizations. SCPs are attached to the organization root, or more commonly, at an organizational unit, OU level, which contains multiple AWS accounts. They primarily function using deny statements.
Okay.
When any IAM principal, a user, or role in an account within that OU tries to perform an action, the request is checked against the SCPs first. If an applicable SCP contains an explicit deny for that action, for example, deny action s3.delete bucket on resource, then the action is blocked right there.
Even if the user's own IAM policy grants them s3.delete bucket or even full administrator access.
Even then, the SCP acts as a master filter at the very top of the policy evaluation chain for that account. An explicit deny in an SCP always wins and cannot be overridden by IAM policies within the account.
So you can use an SCP to enforce a truly non-negotiable security boundary across your organization, like ensuring a fundamental requirement like, say, Control AU9 from NIST 853 Protection of Audit Information is always met.
Precisely. That's a classic use case. You could apply an SCP at the OU level containing all your production accounts that explicitly denies the CloudTrail. Delete trail and CloudTrail. Stop logging actions.
So even a compromised administrator account within one of those production accounts literally cannot delete the organization's central CloudTrail logs or stop them from recording.
Correct. The SCP prevents it systemically. This ensures those critical receipts remain intact for audit and investigation purposes, regardless of what happens with permissions inside individual accounts. It sets a non-negotiable baseline.
Okay, so we've got monitoring with config, aggregation and compliance checks with Security Hub, the activity log with CloudTrail, access control with IAM, evidence collection with Audit Manager, and preventative guardrails with SCPs. That's a powerful set of tools. But all this activity must generate just massive amounts of raw data, right? Complex JSON objects from APIs, log files.
Oh yeah, potentially terabytes of it.
So how do you effectively query all these different services, pull out that raw data, and then critically turn it into something genuinely useful and understandable for executives, auditors, or even the engineers themselves? This sounds like where Python comes into the GRC engineer's toolkit.
Exactly. Python is really the preferred language for this kind of GRC automation and data wrangling on AWS, for a few key reasons.
Why Python specifically?
Well, first, its readability and relatively gentle learning curve are big pluses. But the main reason is its incredibly rich ecosystem, especially for AWS. Crucially, it gives us Boto 3.
The official AWS SDK for Python.
Right. Boto 3 lets GRC engineers programmatically interact with virtually every AWS service. You can write scripts to query Security Hub for findings matching certain criteria, pull non-compliant resource lists from config roles, search CloudTrail logs for suspicious API calls. Anything you can do in the console, you can automate with Boto 3. It's infinitely more scalable and efficient than manual clicking.
Okay, so Bodo 3 gets you the raw data, but you said that data is often messy, nested JSON. How do you clean it up?
That's where the true transformation happens, using the Pandas library. Pandas is the workhorse for data manipulation and analysis in Python. Raw JSON, returned by AWS APIs, can be gnarly, deeply nested structures, lists within dictionaries within lists.
Hard for humans to parse.
Very hard. A GRC engineer uses pandas functions, particularly pandas.json normalize, to take that complex, nested JSON output and elegantly flatten it into a structured data frame. Think of a data frame as just a clean two-dimensional table, like a spreadsheet, where every row represents a specific finding or a configuration item, and every column is a specific attribute.
And that flattening process is vital for making the data usable.
Absolutely vital for communication. Imagine trying to explain a multi-level nested JSON object to an auditor or an executive. Their eyes would glaze over instantly. But showing them a structured pandas data frame, easily exported to Excel or CSV, with clear columns like resource ID, OS accounted, compliance status, severity label, first observed at. That's immediately consumable and understandable.
But the real value add, as the sources suggest, comes from adding those business logic columns, right? Going beyond just the raw AWS data. Can you give us a concrete, actionable example of how a GRC engineer uses pandas to transform that raw data into actual business intelligence?
Sure. Let's take that earlier example. AWS Config flags a finding with a technical severity of medium. Maybe it's an EC2 instance running an operating system version that's slightly out of date but not critically vulnerable yet. The raw data from config via Bodo 3 might just show the instance ID, the rule violated the technical severity.
Okay, standard stuff.
But the GRC engineer knows, maybe from applying question 2, what would failure cost us, or just from internal context, that this specific EC2 instance isn't just any server. It hosts the primary database for their single largest enterprise customer, let's say ACME Corp. And maybe this instance is tagged appropriately in AWS with something like customer, ACME, or data classification, high business impact.
Right. The raw config finding itself is missing that crucial business context.
Exactly. So the GRC engineer writes Python code using pandas. First, they pull the resource tags for that EC2 instance using Bodo 3. Then they merge that tag information into the main data frame containing the config findings. Now they can apply business logic using pandas filtering and column creation. If the severity label column is medium, ADD, the merged resource tag, customer column is ACME or the resource tag, data classification column is high business impact, then create a new column called business priority score and set its value to critical P1 incident response required.
Wow. So you've just programmatically used data analysis, combining the technical finding with business context from tags to completely reprioritize that seemingly medium risk issue into a critical one that demands immediate attention.
Precisely. You've just used Python and pandas to prioritize your technical debt remediation efforts based on quantified business impact and contractual obligations, not just relying on the raw technical severity score provided by the tool. That's the power of bringing coding and data analysis skills into the GRC domain. You make compliance data smarter.
Okay, this is great. We've got the philosophy, the principles, the pillars, the AWS tools, the Python magic. Let's put it all together now and see how it works in the real world with that FAFO case study you mentioned. So FAFO was a rapidly growing SaaS company.
That's right. And they were facing that typical compliance nightmare that many fast-growing tech companies hit. They needed to pass their SOC2 Type 2 audit, essential for closing enterprise deals. But their previous audit had been incredibly painful.
Painful.
The sources indicated it devoted approximately 380 precious engineer hours away from core product development and into just gathering evidence, answering auditor questions, sitting in meetings.
Oof, that's almost 10 full engineer weeks down the drain on audit support.
Exactly. That time drain is the huge, often hidden cost of traditional manual GRC. So their mission for the next audit cycle was crystal clear. Cut that audit burden significantly. Their initial goal was in half, but they actually achieved an 87% reduction and do it using only AWS native services and maybe some open source tools were necessary. No expensive third-party GRC platforms.
And they focused on specific SOC2 areas.
Yeah, they focused heavily on automating the evidence collection for controls in the common criteria related to logical access, CC6, change management, CC7, and system operations, CC8, plus some of the availability A-series controls. These are the areas that map most cleanly to infrastructure configurations and automated checks within AWS.
Okay, so what was the first practical step they took? Establishing that automated evidence baseline.
Right. They didn't try to reinvent the wheel or build everything from scratch. They smartly decided to leverage the built-in compliance standards available within AWS Security Hub. specifically the AWS Foundational Security Best Practices, FSBP standard, and also the CIS AWS Foundation's benchmark standard.
These are curated sets of automated checks provided by AWS and CIS.
Exactly. They cover hundreds of common security best practices and configuration checks across various AWS services. So, FAFO adopted this strategic approach we sometimes call enable and prune.
Enable and prune, how does that work?
First, they enabled the entire FSBP and CIS standards across all their relevant AWS accounts using Security Hub. This immediately gave them a broad baseline assessment. Then, they ran it for a bit, exported all the findings, the passes, and the failures.
Okay.
Next came the crucial mapping step. They sat down and carefully mapped the specific technical findings generated by those FSBP and CIS rules, like config rule X failed for resource Y, to the higher-level narrative controls required by the SOC2 framework, like CC 6.1, logical access security controls are implemented.
So connecting the technical check to the compliance requirement.
Precisely. And once they had that mapping, they could then strategically prune, meaning disable any specific FSBP or CIS checks that genuinely didn't apply to their specific environment or risk profile. For instance, if they had fully migrated away from using AWS's deprecated classic load balancers, there was no point having Security Hub constantly checking for classic ELB security settings.
Right. Disabling irrelevant checks reduces noise and keeps the focus sharp on what actually matters for their audit.
Exactly. It keeps the signal-to-noise ratio high.
Then they used AWS Audit Manager.
Yes. They took that mapping they created and used it to build a custom SOC2 framework directly within AWS Audit Manager. This involved precisely configuring Audit Manager to understand that, for example, SOC2 controls CC 6.1.den, which might relate to data encryption at rest, should automatically collect evidence from specific FSBP rule IDs, like S3.4 or RDS.13, that verify S3 bucket encryption or RDS database encryption are enabled.
So they explicitly taught Audit Manager which technical checks provide evidence for which SOC2 controls.
Correct. And once that custom framework was set up, Audit Manager started doing its job, continuously and systematically collecting the evidence from Security Hub and Config, organizing it against the SOC2 controls 24/7. The auditors theoretically would never have to manually ask, where's the evidence for Control X, because Audit Manager was constantly gathering it into the assessment.
Okay, that handles a lot of the infrastructure-level evidence. But auditors also need proof of application security practices, right? Things like SAST, static application security testing, and BAS dynamic application security testing scans, code reviews. How did FASO handle that? Often that data lives in different systems.
That was exactly the gap they identified. FAFO was using GitLab for their source code management and CI/CD pipelines, and GitLab has built-in SAST-DAST scanning capabilities. But the results from those scans were completely siloed within GitLab. They weren't feeding into that centralized AWS evidence picture.
Which meant someone probably had to manually pull those reports from GitLab and give them to the auditors separately.
Right. More manual work, more potential for inconsistency. This required closing that application security evidence gap, which, as you say, is often the weakest link in compliance automation efforts.
So what was the integration solution? More Python.
You guessed it. They engineered a clever Python script that ran as a step within their standard GitLab CI/CD pipeline, right after the SAST-DAST scans completed.
Okay, what did the script do?
It performed 3 key steps automatically within the pipeline run. First, it located and extracted the scan results, which were in GitLab's proprietary JSON report format.
Got it. Step 2.
Step 2 was the transformation. Using Python libraries, it parsed the GitLab JSON and meticulously transformed the relevant findings into the Amazon Security Finding format, ASFF.
Ah, ASFF again. You said this standard format is critical for interoperability.
Absolutely critical. ASFF provides that common standardized schema for describing security findings, things like severity, description, resources affected, remediation recommendations. Because the GitLab findings were now in ASFF, AWS Security Hub could understand them just like it understands findings from GuardDuty or Config. Without a standard format like ASFF, Security Hub simply can't ingest and consolidate data from diverse sources effectively.
Makes perfect sense. And the third step of the script?
The script then used the Boto3 FDK to securely send those newly formatted ASFF findings directly to the AWS Security Hub API endpoint.
Brilliant. So the application security findings just flowed into the same central hub as the infrastructure findings.
Exactly. This achieved that unified, continuous evidence trail they were aiming for. Now, critical application security findings related to things like input validation flaws or improper access control in the code, which map to SOC2 controls like CC 7.2 change detection or CC 8.1.5 application security testing, automatically populated into Security Hub, and from there, flowed into AWS Audit Manager alongside all the infrastructure checks.
So the auditors see one single, unified, authoritative source in Audit Manager for pretty much all the technical control evidence, infrastructure, and application level.
That was the outcome. A huge reduction in complexity and manual correlation effort.
Okay, that's incredibly slick.
Yeah.
But there's still the final step, right? Getting this nicely consolidated evidence out of Audit Manager and into the hands of stakeholders and auditors in a usable format. How do they automate that last mile? This sounds like the famous Friday Excel report you mentioned.
Yes, the Friday Excel. This was the piece that eliminated probably the most tedious manual work. The weekly or monthly scramble to pull data, format reports, and email them out.
So how did they solve it?
Pure GRC engineering efficiency. They built a scheduled AWS Lambda function configured to run automatically, say, every Friday morning at 8 a.m.
Okay.
This Lambda function executed a Python script. The script used Boto3 to query the AWS Audit Manager API, pulling the latest assessment status and evidence collected for their custom SOC2 framework.
Got the data, then.
Then it used the Pandas library again to process and format that raw evidence data into a really professional multi-sheet Excel report ready for auditors and management. Crucially, they designed the Excel file to contain multiple tailored sheets. Maybe an executive summary sheet with high-level pass-fail counts by control domain, a detailed control status sheet showing each SOC2 control and its current evidence status, and a failed findings detail sheet listing only the currently failing checks, perhaps enriched with that business logic priority score we discussed earlier so people knew what to focus on.
That's incredibly useful, different views for different audiences in one report. And how did they handle delivering the report securely? They didn't just email the Excel file around, I assume.
No, absolutely not. Security was key. The Lambda function, after generating the report, securely uploaded the Excel file to a specific version-controlled S3 bucket with very strict access policies.
Okay.
Then it generated a secure, pre-signed S3 URL for that report file. This URL provides temporary, time-bound download access. Maybe it was configured to expire after 24 or 48 hours. Finally, the Lambda function composed and sent an email to the designated stakeholders, compliance team, relevant execs, maybe the external auditors, containing only that secure expiring download link.
So the sensitive report data itself never transits insecurely via email, and access automatically expires. Very clever.
Exactly. And the quantitative impact here is what really sells the whole GRC engineering discipline. The sources stated this automated reporting system, combined with the other automation, achieved that 87% reduction in the total engineer hours spent directly supporting the SOC2 audit process compared to the previous year.
87%. That's phenomenal.
And it resulted in a 100% elimination of the weekly manual effort previously spent just preparing status reports. They literally gave hundreds of hours of high-value engineering time back to the business, allowing them to focus on building product, not wrestling with spreadsheets for auditors.
That is the definition of turning compliance from a cost center into an operational asset. Just incredible efficiency gains. But there was one final layer of friction they eliminated, wasn't there? Providing auditor self-service access.
Well,
you mentioned the biggest bottleneck often becomes the human gatekeeper needing to provide things.
Right. Even with automated reporting, auditors often still have follow-up questions or want to dig deeper into specific evidence samples. AFO decided to eliminate that human interaction bottleneck almost entirely during the audit period.
How? By giving auditors direct AWS access. That sounds risky.
It sounds risky, but they did it very carefully. They created a dedicated IAM role specifically for their external auditors. They didn't give them IAM users. This role was crafted with extremely restrictive read-only permissions, scoped down only to the AWS Audit Manager service, and perhaps read-only access to specific S3 buckets where Audit Manager stores the underlying evidence files. Nothing else.
Okay, read-only makes sense, but what other security controls were wrapped around that auditor role?
They locked it down tightly. First, the role policy absolutely enforced the use of multi-factor authentication, MFA, for any auditor assuming the role. No MFA, no access. Second, it required the use of a specific external ID during the role assumption process.
External ID, what's that?
It's a security best practice for cross-account access. It's basically a unique secret string that FAFO provides to the audit firm, and the auditor must include that exact string when they try to assume the role. It prevents the confused deputy problem, ensuring only the intended audit firm can use the role, even if the role's ARN somehow leaked.
Got it. Extra layer of assurance. Anything else?
Yes, crucially, the access granted by the role was time-bound. They likely configured the role's session duration to be relatively short, and perhaps even use IAM conditions or external tooling to ensure the role could only be assumed during the officially scheduled audit fieldwork period. Outside that window, the role was effectively inactive.
So MFA enforced, external ID required, read-only permissions, tightly scoped, and time-bound access. That sounds pretty robust.
It is. And the outcome was that the auditors gained significant autonomy. They could log in, assuming the role securely, and view the live evidence directly within AWS Audit Manager 247 whenever they needed to during the audit period. They could drill down into findings, review evidence history, export reports themselves, all without needing to constantly ask a FAFO engineer to manually pull things for them.
That makes the audit process truly frictionless, almost autonomous from the engineering team's perspective. And it also demonstrates a high degree of transparency and confidence from FAFO to their auditors.
Exactly. It builds trust and massively reduces the interrupt-driven workload on the internal teams during that critical audit window. It was the final piece in fully operationalizing their GRC engineering approach.
Okay. The FAFO case study is incredibly compelling. It really proves that this GRC engineer role is becoming absolutely critical. It's the essential hybrid function bridging, as you said, that often slow, process-driven world of traditional compliance and the incredibly fast-moving world of modern cloud engineering.
It really is that bridge.
Yeah.
And success in that role depends just as much on the human skills as the technical ones. You need to be technically deep enough to actually build these automated pipelines and control systems.
But also human enough, persuasive enough to get those systems adopted and used effectively across different teams, right?
Absolutely. The soft skills are non-negotiable. You often have to act as the universal translator.
Universal translator, meaning?
Meaning you have to be adept at translating granular technical details, like the specifics of an SCP policy or the output of a vulnerability scanner, into clear, measurable business impact that executives can understand and care about. You can't just walk into a boardroom and list the number of medium-severity S3 findings from Security Hub.
They won't care.
No. You have to frame it in terms of risk reduction or cost savings. You need to compare the cost of the manual audit process last year versus the projected savings from the automation you're building this year.
So what does that translation look like in practice? How do you take a technical configuration change and turn it into compelling business terms?
Let's use that error budget example again, or maybe the policy as code for encryption. The GRC engineer doesn't just say, we implemented an SCP to enforce database encryption.
Okay.
They explain the outcome. By implementing policy as code to automatically enforce database encryption at deployment time, we've effectively shrunk our potential exposure window for non-compliant databases storing sensitive customer data from potentially 90 days, our old annual review cycle, down to effectively 0 seconds for new deployments, and maybe 120 seconds for drift remediation.
That's a quantifiable improvement.
This shift, they continue, based on industry data for breach costs per record, reduces our maximum potential financial exposure related to unencrypted sensitive data by over 99%. It also directly addresses Control XY in our SOC2 report. Now, that's a language executives understand. Reduced risk, quantified impact, compliance achieved.
Okay, translation is key. What other soft skills are vital?
Collaboration is huge. The GRC engineer often sits between teams with naturally competing priorities. The central security team might want total lockdown on everything. The DevOps and application teams want maximum velocity and flexibility to innovate.
That classic tension.
It is. And the GRC engineer has to be the facilitator, the arbiter, finding those win-win solutions. They don't just enforce the security rule, they actively provide the path of least resistance to meeting that rule. They build the pre-approved secure IAC modules, they integrate the checks seamlessly into the existing pipelines, they provide clear, actionable feedback.
So they enable the DevOps team to move fast safely by building the guardrails into the road they're already driving on.
Precisely. That's how you move from just saying no to effectively saying yes, and here's the secure and fast way to do it through this automated pipeline we built together. It requires empathy and negotiation skills.
And finally, adaptability, I imagine. The tech and threat landscape changes constantly.
Constantly. You must view, change, new regulations coming down the pipe, new AWS services being released, new vulnerability classes being discovered as an opportunity, not just a burden. An opportunity to improve the automated systems, to refine the controls. This often means having the curiosity and the problem-solving mindset to ask why. 5 times, like the Toyota Production System teaches, to find the systemic root cause of a recurring issue, not just keep patching the surface symptom.
Okay, so strong translator, collaborator, adaptable problem solver. What about the core technical competencies? What absolutely has to be in their toolkit?
Well, as we discussed, cloud platform mastery is foundational, specifically for AWS GRC. That means deep, hands-on understanding of the compliance applications of AWS Config, Security Hub, CloudTrail, IAM, including advanced features like permission boundaries and SCPs, and increasingly services like AWS Systems Manager for patching and automation, and of course, Audit Manager.
They need to know these services inside out from a compliance perspective.
Yes. And second, automation and scripting proficiency is non-negotiable. That primarily means Python, using Boto 3 to interact with AWS APIs, and using Pandas for data manipulation to build those systems that continuously monitor, analyze, report, and ideally auto-remediate compliance issues. They need to be comfortable writing code that manages infrastructure and enforces policy.
I bet there was a specific moment, maybe during that FAFO audit after they implemented all this, when the engineering team truly realized the game had changed.
Oh, I'm sure. The sources didn't capture a specific quote, but I can easily imagine the lead DevOps engineer turning to the GRC engineer halfway through the audit period and saying something like, wait, I haven't manually gathered a single piece of evidence or had to sit on a 3-hour call with an auditor in 3 weeks, and my deployment pipeline still ran successfully this morning.
Yeah.
This is kind of terrifyingly efficient.
Oh, that's the reaction you want.
That's the win. The GRC engineer is ultimately the professional who can confidently walk into any boardroom or any technical review and say, look, I know exactly how to automate SOC2 compliance or PCI or whatever using AWS Native Services and code. We did it at my last place, and I can show you the metrics, the 87% reduction in engineering overhead, the near real-time evidence generation.
They move beyond just talking about checklists to demonstrating working code and measurable results.
Exactly, and that's why they're becoming so incredibly valuable in the job market right now. They solve a massive pain point for cloud-native organizations. Hashtag tag outro.
So wrapping up this deep dive, we've really unpacked the GRC engineering mindset that shift from manual checks to automated code. We've defined the technical and strategic foundation, focusing on those key AWS services and the power of Python for automation and data analysis.
And we saw through the FAFO case study how this transformation isn't just theoretical. It tangibly eliminates friction, it protects precious engineer productivity, and ultimately it turns compliance from a dreaded cost center into a genuine source of operational efficiency and even competitive advantage.
It really feels like the traditional model of compliance, so manual, document-driven, and static. It just fundamentally cannot scale or keep pace with the velocity and complexity of modern cloud development practices. It's built for a bygone era.
I completely agree. The future of governance, risk, and compliance, especially in the cloud, clearly belongs to the engineers, those who can translate abstract rules into verifiable automated code, not primarily to the auditors who are just checking the boxes after the fact. The engineers build a compliant state, the auditors verify it more efficiently.
So we've laid out the blueprint for this transformation. For everyone listening, you now have this strategic framework. You know the key AWS tools. You see the potential of automation. The final thought we want to leave you with is this. Thinking about your own organization, what is the first manual compliance task, the one that causes the most pain, the most friction, the most wasted engineer hours that you will choose to target, to automate, and to transform into elegant, efficient code?